Hi, and welcome back to the Art of Software Development. Today I've got another electronics video. We're going to be finishing populating this board. The story starts a couple years ago, and several years ago someone had bought me this board. This is a kit. You get a bunch of through-hole components, you solder them on, and at the end you have a functional FM radio. This is a really cool kit, and I highly recommend it if you know anyone who's interested in electronics. And seeing this board really inspired me, and so I got the idea that I would design my own board inspired by theirs that would implement an FM radio. I found the data sheet, and here it is. I had to kind of turn my head to the side to look at this until I realized I could just rotate it. And here's the circuit. The thing that's in the inside is the chip, but it has all the reference pieces of how you would build this yourself. And here's the data sheet of the amplifier. And here's how you set it up with gain. It has a bunch of reference circuits of how to do this. So I went ahead and I used KiCad to make up a schematic. And this is mostly the reference circuit for the FM chip. This is mostly the reference circuit for the amplifier. There's a little bit of power and a little bit of connecting back and forth. And then I didn't really want to have a battery. My original board has a 9-volt battery. But I have a power supply, so for my purposes, I just put in a connector to do that. And I put in a connector so that when I'm all done, I can measure the outputs and put them in an oscilloscope. I don't want to pretend like this was super easy because this was all new to me, but the data sheets really helped a lot. They have a lot of the circuitry pre-designed, and so I was able to get the basic idea of what to do and then just go through and be very careful to build the right schematic. And then I laid out the circuit board using KiCad. This was also very new to me. I had done a very simple board before that all it had was some connectors on it. This one's a lot more complicated because it has chips and it also has signals, so I had to worry about noise characteristics. And one of the cool things I learned is you could make a ground plane. I learned all about that. I watched some YouTube videos about how to do these different things, and I laid the whole thing out. And here's something important. As I was doing the schematic, there are different parts you have. There's obviously the chip, but then some of the diodes are special. There's a BB90 diode you use, and the antenna and different things like that. And so what I did, as I was doing this, I would go through and I would open each of the things, put in the right footprint, link to the data sheet, but also I found these things on DigiKey, and you can add a custom field. So I just added a field that was the link to where to get this on DigiKey. If I paste in that link, you can see here's the switch. And for some of the things like an 0805 capacitor, who cares, right? It doesn't matter. But once I had figured out what parts I wanted for anything that was even a little bit weird, I went ahead and put that in and kept the link so it would be much easier to work with later. So when all of that was done, I went ahead and exported the BOM. You can see quantity 1, quantity 2, quantity 6, values, and then it has all those links. So when I go to do my order, it's really easy. I just start at the top and go click all the way through. I went through and ordered all the components. And then I went to this site, PCB Shopper. Now what this lets you do, I wanted to do fabrication of a circuit board. So you put in your dimensions, like mine is 3 inches by 4 inches, which I measured from KiCad. And you fill in all the different things you want. And then you go ahead and you get prices. Let's see, quantity. I'm just going to go ahead and say I want 10 of them. And what you'll see is you get a whole bunch of different possible places that all cost different amounts of time. And there are several variables here. How much it costs, how much shipping is. Like you can see for this one, the cheapest thing I should get in 16 days, but then I can pay more money and send it this way and get it in 31 days. Or I could send it FedEx IP and get it in 6 days. So you can figure out different options there. And then the ones in China, typically the board cost is cheapest. The ones in Europe or the States, the board costs tend to be a little more expensive. Since I'm in the US, the ones in the US, typically the boards are more expensive, but maybe the shipping's a little bit cheaper. And sometimes the lead time is better. Anyhow, cool site, highly recommended. So for this video, I just put in some random numbers and clicked get prices. For the actual board, I put in all the real stuff, including what I needed. And then you get the actual prices. So my favorite part of this whole process is once you're all done that and everything's ordered, and then you're just waiting around because every day you get a package or 2 or 3, and you put that in your box and that becomes your kit. And I was super excited because I made the Rev 1 board. And everything was going great until I tried to populate it, because it turns out there's a problem with the U1 chip. And here's the problem. If I line up the top row of pins, it's nowhere close to the bottom row of pins. If I line up the bottom row of pins, it's nowhere close to the top row of pins. Because I used the wrong sized footprint for this chip. Some of my electrical engineering friends said put the chip on anyway and use little wires to bridge the gaps, so I tried that. And to be honest, this was just a mess. And it really didn't work at all. So back to the drawing board, and I did another revision of the board. In the meantime, the pandemic happened, so some time went by, but eventually I got a new set of boards in. In my last video, you saw me get these boards and populate all of the surface mount components on it. By my count, there are 40 surface mount components, and there are still a couple missing pieces. I need to do all of the through-hole components, and there are about 8 of those, and then there's the antenna, which is on the other side of the board. I originally planned in the current video to do a tutorial of how to do through-hole soldering, but I'm really rusty on through-hole soldering, so I made it work, but it didn't look very good, and there are much, much better tutorials on YouTube for how to do that. So I'm instead just going to give you a quick montage of all the pieces that we do. Here's the first button. Here's the second button. Here's the speaker. Here's the 4-pin connector, and the 2-pin connector, and the switch, and the diode. And finally the antenna, and that involved a little bit of hot air as well as solder. All right, so now we're going to do the bring up. Here's the board. Pull the antenna out nice and big. Over here we have power. Let's turn on the power supply. It's set to 9 volts. Power switch. You can see the LED. Here's the reset button. And now this changes radio channels. All right, and this sounds like it's just a volume, but it's actually a filter. For comparison, here's the original board with through-hole components and my board with surface mount components. I hope you've enjoyed this video. Please like and subscribe.